What up? Let's do some more integration. Today, evaluate by writing as the sum of two integrals and interpreting one of those in terms of an area. Okay, and then we have this thing here. Okay, weird. Let's try and piece that together. So they want us to evaluate by writing it as the sum of two integrals. Well, the one way we can split that is we can distribute this x minus 5 term. So we can go x times this junk here minus 5 times this junk here. That's really the only way we can split this one up, because you can't distribute over the root sign. You couldn't do 49 times x minus 5 minus x squared times x minus 5 because you have the square root thing here. So really, we only have one option in terms of distributing and splitting this up as the sum of two integrals. So we do that. Okay, so if I can bring your attention over here, we split up into green and red. Okay, and this is the step that I just described with distributing the x and the 5. So yeah, you get x times this junk minus 5 times this junk. Notice that the integral is still from the same bounds. It still has the same bounds of integration. So you can do that with integrals. Okay, it splits over sums. So yeah, like if this integral wasn't here and you just had x minus 5 times root 49 blah blah blah, you could split that into two things. It would be x times this stuff minus 5 times that stuff without the integral signs. But anytime you have a sum of things and you want to take the integral of a sum of things or a difference of things, meaning a plus or minus in here, it's always the integral of one plus or minus the integral of the other. The integral splits over sums and differences. Okay? So, yeah, so now we can look at these two things separately. So the first one here, what you'll notice, or what you want to get trained to notice, is that what you're taking the integral of here is an odd function. Odd meaning that, like if you were to graph it on your axis here, it goes through 0, and like whatever happens, you just have to make sure the opposite thing happens as you move away from the center. Okay, if it's not the opposite thing that happens, it's not an odd function. That's kind of the geometrical way to see it. The algebraic way to see it is that if you go f at negative x, it equals negative f at x. Okay, you need to be good at doing odd functions. Okay, I didn't do a full description here, but you're going to see that time and time again. So know how to recognize an odd function, know how to recognize an even function. Knowing both those things is going to make your life a hell of a lot easier, as we're going to see here. Okay, so yeah, this is an odd function. Another way to see it, there's a little trick. This is an even function because anytime you put in a negative value, it's going to square it and kind of absorb that negative. So it spits out a positive whenever you put in a negative. That's kind of how you can think of an even function. And the function just y equals x is an odd function, and an odd function times an even function returns an odd function. Okay? Yeah, so take a look at that and know that for sure. Now, this other thing here, what the heck is going on here? So first of all, I have an integral of 5 times some stuff. That means I can take the 5 out of the integral. Okay, you can always factor out a constant from the integral. It's going to be 5 times your area in the end. Okay, what the heck is this stuff here? When I see this, I think of triangles or I think of circles. Okay? You'll see why for triangles later when we do something called trig substitution. It's one of the techniques we know for integration. But for right now, I'm going to think of it as a circle who's centered at 0, 0. If you look at this formula, you have to know the formula for a circle. So if you don't, study up, go to Khan Academy, figure out what you got to know the equation of a circle. This is it here. X squared plus y squared equals 7 squared. You need to know where this is centered. It's centered at 0, 0. Otherwise, it would be like x minus 2 squared, y plus 7 squared or something like that. And the radius here is 7. It's not 49, it's 7. Okay. Now if I rearrange for y, I get y squared equals this stuff here. And then if I take the square root of both sides, I get that y is equal to plus or minus square root of 49 minus x squared. This represents the top half and the bottom half of the circle respectively. Y equals plus square root of 49 minus x squared is the top half of the circle. Y equals negative 49 minus x squared is the bottom half of the circle. Okay. So really, when we look at our integral and we say square root of 49 minus x squared, since it's a plus out in front there, that's the top half of a circle of radius 7. So if we're taking the integral of that, okay, well, hang on, let's just follow through here. I read it out. So, okay, so we're up here now. If we take the integral of that, it's just the same thing as 5, or like the negative 5 here, I've taken out to the front. That's this negative 5 here, times pi r squared over 2. Why pi r squared over 2? Well, pi r squared is the formula for the area of a circle. and divided by 2 because I don't want the full area. I just want the top half area. Okay, so I just need to input whatever my area is, and it's 7. So 7 squared, blah, blah, blah. There's my answer. Oh, I meant to put a 49 there, but I didn't. That's totally fine. Right, so remember when you take the integral of something, it means return to me the area of that thing, the area under that curve. Well, if this square root 49 minus x squared is the top half of a circle and you integrate over that, you're going to return the area of the top half of that circle. Now, the other thing to check is that when it goes from -7 to 7 here, that's good. We need that because otherwise you may just be integrating a portion. If you integrated, for example, from -5 to 5, you wouldn't be able to use this formula directly because it wouldn't be getting the whole arc of the circle, which goes from -7 to 7 on the x-axis. So we really did need it to go from -7 to 7 to use our trick. The other one that would have been okay is if it went from 0 to 7, because that would have been just a quarter of a circle. So we would have been able to do that one also. Anything else, we would have actually had to integrate. We would have had to use an integration technique to do it, as far as I can think of right now. I don't see another shortcut to do it, which would have been a lot more complex. But yeah, so that's pretty much the gist of this question. Hopefully that helps you. If you have any other questions, let me know. Shoot me an email or the Facebook group or whatever. And yeah, we'll see you on the next video. So, pieces.